Okay, this is formative task 19, question 22. So for part A, we're going to use product rule. U is equal to x squared, v equals e to the k x. So now we've shown that that is a derivative, and that's a bit of a clue too, that the question's asked us to show that and it's given us the answer. That's a clue, but it's probably going to be asking us to use that later on. Okay, in part B, we want an intersection. So we want to know where these two things are equal. Now in this step here, I'm just dividing both sides by x and dividing both sides by e to the kx, but I have to remember that that's going to eliminate this answer. So I'm looking where these are equal. One of the possibilities is x equals 0, then I'll just get 0 equals 0. By dividing both sides by x, I'm allowed to do that, but I have to remember that that solution is still part of it. And that's my other possible solution. Perhaps I should put it in the line working so there's no confusion. X minus kx equals 2x outside of 1 minus k equals 2, therefore x equals 2 over 1 minus k is where I got that from. So now we've got two answers, x equals 0 or x equals that. They're my two x values that give me an intersection. I want to know where I can only have one solution, one intersection. So that comes from this one here. If k equals 1, this becomes undefined, and so therefore that's no longer a solution. The only solution we have then is x equals 0. So that's our answer, k equals 1. Alright, part C. Okay, so in part C, I'm noticing that this and my derivative over here are similar. So I'm getting it to look the same, so I can use integration by recognition. Now I've got this here, is this derivative that we found earlier. Since I know that that is the derivative of our original function, then I can use that to integrate by recognition and just say that it's got to be our original function. Running out of space. So I get an expression for that integral, and that's got to be equal to 16 over k for the last bit. Divide both sides by 4. Oops, sorry, that's the one, okay. Yeah, and that gives me the last bit there. Okay, formative task 19, this is question 23. So we've got our graph. That looks something like that. The first thing to spot is that this area fits nicely in here. That one fits nicely in there. And so the entire area, once you've cut that out, put it in there, cut that one out and put it in there, the entire area is the equivalent of the area under that bigger 2 sine x graph. So therefore the area is equal to 2 times the area from 0 to pi of 2 sine x, which you can write as four times sine x. So our A value is 4. Okay, 23 part B. We need to draw that graph. That function is going to have 3 periods now within our shape. It's going to look something like that. It's going to have 1, 2, 3 periods fitting in that shape. And it's got an amplitude of 1/3. So in part C, where it talks about the transformation is just dilations, isn't it? So it's going from here, squashing down to 1/3 of that, so that's going to be 1/3. dilation 1/3 from y-axis, and this one is squashing that one, and it's going from 2 down to 1/3. So I'm multiplying 2 by 1/6 to turn it into 1/3. So dilation 1/6 from x-axis. Then my pair of transformations that have happened for part C. Okay, for part D, the area enclosed between these two functions, we subtract them, we take the integral between 0 and pi and double it, so that's okay. If I do that integral, I get that. Now the key to this one is that if n is an even number like 2x, 4x, 8x, then when you substitute the pi into it, it'll be 2 pi or 4 pi or 8 pi, and for all of those, cos is going to come out to be +1. Whereas if you substitute a odd number in for n, then you're going to have something like 3 pi or 5 pi or 7 pi when you put that pi into the function, and then your value will come out to be -1. So you're always going to get +1 if n's even. You're always going to get -1 if n is odd. Substitute pi in and I get -m times cos of pi, which is -1, and then plus 1 on n squared times, and don't forget cos nx will come out to be 1 if it's even, so it'll just be times 1. And then I've got to take away my -m times cos of 0, which is just -m, and 1 on n squared times cos of 0. Figure that out. And you'll notice that this 1 on n squared cancels with the -1 on n squared, leaving me with 2 times 2m. Now same process for my the odd variety. So pretty much the same sort of calculation. This time those two 1 on n squared terms, instead of having opposite signs and cancelling out, those two end up with the same negative sign in front of them and add together to give me my second possible expression for the area.